Under the expansive sky above a massive crimson star, one of the most brilliant and readily apparent celestial objects rules over the horizon. It exists far beyond our full understanding. A vast cosmic body capable of unleashing energy so tremendous that it could rival the combined brilliance of countless stars. This immense astronomical object, possibly nearing a catastrophic event, may soon erupt violently, so great that its radiance may shine brighter than the collective brilliance of a billion suns. The key question remains, is humanity ready for the aftermath of such an event? This massive red star, frequently referred to as Goliath, lies relatively close to Earth and has become a focal point of intense interest and debate among both the public and scientists. Recently, the star underwent a dramatic change that has raised alarms and ignited heated discussions about its future. The most alarming possibility is that this change could be an early sign of a supernova, an explosive event that marks the end stage of a star's life cycle. If Alpha Orionis, its scientific name, were to run out of nuclear fuel, it could collapse under its own gravity, resulting in a disastrous explosion. Just the idea of such an event raises concern not only for researchers but also for those of us here on Earth, as the potential fallout could be extraordinary. Alpha Orionis, easily distinguished by its deep red color, is the largest and brightest star in the Orion constellation. Employing advanced tools like NASA's Hubble Space Telescope, astronomers have been paying close attention to its behavior, especially in 2019 when it experienced a significant mass loss, a rare occurrence for stars of its type, causing concern within the scientific community. Even as our sun frequently suffers from coronal mass ejections, the unusual events witnessed in Alpha Orionis have led scientists to reassess what happens in the final stages of a massive star's life. There is disagreement among scientists regarding the exact distance of Alpha Orionis from Earth, with some placing it as far as 1,200 light-years away, while others suggest it is as close as 724 light-years. The difficulty in determining its precise location arises from the immense distances involved and the unique nature of red giants. Despite the ambiguity surrounding its exact position, Alpha Orionis remains captivating to astronomers, standing out as one of the most impressive sights in the night sky, shining multiple times brighter than our sun. However, this intense radiance comes at a significant cost, as Alpha Orionis is rapidly consuming its nuclear fuel, hastening its journey toward the inevitable end of its life cycle. Once it exhausts its fuel, the star will most likely fail, forming either a neutron star or, in a more disastrous scenario, a black hole, depending on the nature of the explosion. This leads to an important question. Does Alpha Orionis pose a danger to Earth? If a supernova were to occur within just a few light-years of our planet, the outcomes would be catastrophic. A supernova can release an unimaginable amount of energy, surpassing that of entire galaxies. Even if Alpha Orionis is located a great distance away from Earth, the consequences could still be far-reaching. The most recent supernova in our galaxy occurred in 1604, and since then, humanity has not experienced a similar event on a local scale. However, a notable explosion of a supernova occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While this explosion had significant effects on its immediate surroundings, it posed no direct threat to Earth. These rare events, however, serve as powerful reminders of the enormous scope of supernova explosions and the potential dangers they bring. A supernova, especially one that takes place close to Earth, could create a danger zone around our planet. The dangers to human life from a stellar explosion should be considered within the broader context of cosmic events. While supernovae are relatively rare, gamma-ray bursts, GRBs, represent an even greater threat. These bursts can annihilate entire planetary biospheres by bombarding them with deadly radiation. For instance, GRBs could destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation. The effects of such star-driven events could persist long after the initial burst subsides. This looming danger of GRBs has become a primary focus of current research, providing fresh insights into the potential risks posed by stellar explosions. When massive stars burst into flames, their brightness can outshine entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis underwent a similar transformation? If it were to explode as a supernova, it could become the second brightest object in the sky, after the Sun. In terms of visibility, even at a considerable distance, the energy released in such an explosion could be so intense that it might be visible during the day, providing a stunning yet disconcerting spectacle. Although the visible light emitted by a supernova would undoubtedly be mesmerizing, the real danger lies in the powerful radiation accompanying the explosion. Radiation, most often in the form of X-rays and gamma rays, could have far-reaching repercussions. One of the primary concerns is the potential depletion of Earth's protective ozone layer. Without this shield, life on Earth would be exposed to harmful levels of ultraviolet radiation, which could lead to mass extinction events. The dangers associated with a supernova do not dissipate immediately. The ruins left behind after the explosion, including shock waves traveling at nearly the speed of light, would continue to pose threats as they propagate through space. These shock waves could further damage the ozone layer, exposing Earth to even more dangerous radiation that would intensify over time. Additionally, the effects of the energy released by a supernova could last hundreds of years, leaving long-term damage on the planet. Interestingly, some studies suggest Earth may already have been affected by the aftermath of a previous supernova. Elevated levels of iron-60, a radioactive isotope produced during supernova explosions, have been discovered in deep-sea sediments and lunar soil. This indicates that Earth has likely encountered the fallout from such an event in its geological past, possibly within the last few million years. Currently, no known supernova candidates present an immediate threat to Earth. However, ongoing research continues to uncover new potential risks, particularly from supernovae capable of emitting long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material, and the shock wave from the explosion interact with this material, generating intense X-ray radiation that can travel vast distances through space. This radiation can affect planets within a 150 light-year radius. Fortunately, none of the known candidates are located near Earth. Nonetheless, this research has provided fresh insights into the concept of the habitable zone, the region of space where conditions may support life. It appears that this zone may be more restricted than previously believed. The outer regions of galaxies may lack sufficient star formation to support the formation of rocky planets. On the other hand, the inner regions, where stars are born and die more frequently, may pose risks due to the higher occurrence of supernovae. As scientists continue to explore the remnants of supernovae, in addition to their role in star formation, supernova remnants contribute essential elements to the cosmic environment. During a star's explosive death, heavy elements such as iron, calcium, and gold, formed through nuclear fusion within the star, are scattered into space. These elements eventually become part of new planets, moons, and even life forms. In fact, many elements found in Earth's crust and within our own bodies were forged in the cores of long-extinct stars. This process of element dispersal underscores the profound connection between cosmic events and life on Earth, highlighting how humanity itself is composed of star stuff, as famously stated by Carl Sagan. Beyond their elemental contributions, supernovae also play a crucial role in shaping galaxies. The shock waves produced by these explosions can trigger the collapse of interstellar clouds of gas and dust, initiating the birth of new stars. However, these same shock waves can also disrupt star formation by dispersing gas and dust too quickly for gravitational forces to pull them together. This duality, both promoting and inhibiting star formation, illustrates the complex and delicate balance that governs the evolution of galaxies. One notable example is the Crab Nebula, the remnant of a supernova observed by Chinese astronomers in 1054. Today, The Crab Nebula serves as a natural laboratory for studying the physics of high-energy phenomena, from particle acceleration to magnetic fields. Its pulsar, a rapidly spinning neutron star left behind after the explosion, emits powerful beams of electromagnetic radiation, providing insights into the behavior of matter under extreme conditions. The study of such remnants continues to advance our understanding of both astrophysics and the broader workings of the universe. Supernovae also have implications for the future of space exploration and humanity's long-term survival. As we consider the possibility of colonizing other planets, understanding the potential threats posed by stellar explosions becomes increasingly important. A supernova occurring too close to a human colony could have devastating effects, from radiation exposure to disruptions in communication and navigation systems. Consequently, scientists are working to identify potentially hazardous stars and develop predictive models that can provide early warnings of impending explosions. Moreover, studying supernovae may offer clues about the ultimate fate of the universe itself. By measuring the brightness of distant supernovae, astronomers have discovered that the universe's expansion is accelerating, an observation that led to the groundbreaking concept of dark energy. This mysterious force, which appears to counteract gravity, is now believed to make up approximately 68% of the universe's total energy. Yet, its true nature remains one of the greatest mysteries in modern physics. Further research into supernovae may help unravel this enigma, shedding light on the fundamental forces that govern the cosmos. Looking ahead, advancements in observational technology promise to revolutionize our understanding of supernovae and their effects. The James Webb Space Telescope, JWST, launched in 2021, is already providing unprecedented views of distant galaxies and stellar phenomena. Meanwhile, next-generation observatories like the Vera-C Rubin Observatory, set to begin operations soon, will survey the entire sky with unparalleled detail, capturing transient events such as supernovae as they occur. By combining data from these cutting-edge instruments, scientists hope to gain a more comprehensive picture of how supernovae influence the evolution of galaxies, the formation of planets, and the conditions necessary for life. Despite the potential dangers posed by supernovae, their existence is essential to the ongoing cycle of creation and destruction that shapes the universe. Without these cosmic explosions, the elements necessary for life would remain locked within the cores of stars, never to be released into the cosmos. In this sense, supernovae represent both an end and a beginning, a reminder of the universe's ever-changing nature and the interconnectedness of all things. As we continue to explore the mysteries of the cosmos, the study of supernovae will undoubtedly remain a cornerstone of astrophysics, offering profound insights into the origins of stars, planets, and life itself. And while the prospect of a nearby supernova may seem daunting, it also serves as a humbling reminder of humanity's place within the vast and dynamic universe, where even the most cataclysmic events can ultimately give rise to new worlds, new stars, and new possibilities. The power comes from years of stars, the evolution of galaxies, and contributes to the structure of the universe, which changes all the time. Astronomers keep trying to investigate the remnants of supernova, finding that new stars can emerge from these areas. They even contain gas and dust years after the initial explosion. Supernova remnants, with their complex compositions, are also one of the universe's primary sources of heavy elements such as iron, gold, silver, and uranium. These elements are formed under the extreme circumstances of a supernova explosion and are scattered into the interstellar medium, ultimately creating new stars, planets, and even life itself. Without these heavy elements, the solar system, and life as we know it, could not exist. Therefore, supernovae are not just destructive events. They also play a vital role in the creation of the very elements that make up the stars and planets we see today. In addition, the study of supernovae has deepened our comprehension of the universe's growth. By observing type Ia supernovae, caused by the explosion of a white dwarf in a binary system, Astronomers can measure cosmic distances with extraordinary accuracy. These standard candles have revolutionized our ability to map the universe, providing essential information regarding dark energy and the accelerating expansion of space. Despite significant progress in measuring cosmic distances, the potential dangers posed by supernovae cannot be overlooked. While the likelihood of a nearby supernova affecting Earth remains low, the long-term consequences of such an explosion could be profound. As mentioned earlier, supernovae emit intense radiation that could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life to harmful ultraviolet radiation from the sun. Without the ozone layer, Earth's survival would become increasingly difficult, if not impossible. Additionally, the shock waves from a nearby supernova could disrupt the structure of the solar system. These waves could compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a supernova in the vicinity could disrupt the delicate balance of the solar system, resulting in catastrophic shifts in planetary orbits and possibly even threatening Earth's existence. The study of supernovae and their remnants also raises intriguing questions about the future of the universe. As stars die and supernovae occur, their remnants can eventually produce neutron stars or black holes, two of the most enigmatic and extreme phenomena in the universe. Particularly, black holes are regions of space where the force of gravity is so great that not even light can escape. These objects are thought to represent the final stage for the most massive stars, making their formation one of the most fascinating phenomena in modern astrophysics. Despite their destructive nature, supernovae play an integral role in the ongoing evolution of the universe. The substances they release into space serve as the building blocks for the formation of new stars and planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the ever-expanding nature of the universe. In conclusion, while the potential threat of a supernova explosion remains distant, studying these events is essential for advancing our knowledge of the universe. Supernovae not only provide valuable insights into the life cycles of stars, but also offer crucial information about the chemical composition of the cosmos and the ways galaxies evolve over time. As we continue exploring the vast reaches of space, our understanding of these dramatic cosmic events will deepen, offering a clearer and more comprehensive view of the universe's past, present, and future. Supernovae and their aftermaths, such as neutron stars and black holes, represent some of the most fascinating and mysterious aspects of astrophysics. These phenomena raise significant questions about the fate of stars and their role within the larger cosmic structure. The processes leading to a supernova explosion involve extremely complex nuclear physics, yet their resulting impacts stretch across vast distances, influencing the evolution of entire galaxies, the birth of new stars, and the enrichment of the cosmos with essential heavy elements. Understanding how these events unfold and the conditions that trigger them helps scientists piece together the puzzle of stellar evolution and the critical contributions supernovae make to the formation of stars and elements. By observing the light from these dramatic stellar explosions, astronomers can create more accurate maps of the universe, tracing the expansion of space and the distribution of galaxies across vast distances. These measurements are essential for determining the age, scale, and structure of the universe. Such observations have led to revolutionary discoveries regarding dark energy, a mysterious force that appears to accelerate the expansion of the cosmos. The precise ability to measure distances using supernovae has had ripple effects throughout astrophysics, providing more thorough and reliable methods for gauging distances across the universe. As a result, scientists have gained a deeper understanding of the rate at which the universe is expanding and how galaxies are evolving. The presence of dark energy, initially deduced from observations of distant supernovae, has reshaped our understanding of the universe's future, suggesting that the cosmos is not only expanding, but doing so at an accelerating rate. Yet, Despite the incredible knowledge gained from studying supernovae, the potential risks of a nearby supernova explosion remain a fundamental concern. While such an event is unlikely in the immediate future, even the remote possibility warrants attention. The destructive effects of supernovae, particularly the radiation and shock waves they produce, could significantly impact nearby planets. If Earth were within range of such an event, the consequences would likely be disastrous, from ozone layer depletion to disruptions in the solar system's delicate balance. Understanding these risks encourages scientists to think deeply about how cosmic events could affect life on Earth. By continuing to monitor and study supernovae in their aftermaths, humanity can improve its ability to predict and prepare for potential dangers posed by these cosmic giants. While the threat remains distant, supernovae serve as a powerful reminder of the immensity and unpredictability of the universe.